the voltage constant of an electric motor is in a lot of ways like the gears of a bicycle, except for the given motor, the kV doesn't change. So it's like that you have one gear, but you have typically a manufacturer will give you a range of kV values for a given motor, and the kV or the voltage constant is an indication of the RPM that you can expect to get from that motor. And it's a simple formula that you can apply. You take the number of cells in the battery pack, multiply by 3.7, which is the average voltage of a LiPo battery pack, times the kV value. That's the maximum RPM that you can hope to get from that motor. And in reality, it's always going to be less. Of course, if the throttle is not at 100%, if the throttle is at 50%, you're going to get about half that RPM. But also, if you have a propeller, the propeller causes a current, a large current to flow through the motor, and that current is actually a loss, creates a loss of efficiency. So it decreases the RPM. So the only way you're going to get close is if you run the motor without a propeller. But even in that case, you're not going to quite get to that number. So with a propeller, I don't know, maybe you might see a value that's 10% less than the kV will indicate, but it really depends on the application. And the way to change the kV value is to use a different thickness on the winding wire in the motor. And the thinner the wire, the lower the kV. And if the wire is half the thickness, that means it's going to be twice as long, and it's really the length that determines this. So twice as long, you get half the kV. And with the lower kV, you get lower RPM, but you get more torque. And there's a one-to-one trade-off there. And torque is actually really good, because with more torque, you can turn a bigger propeller, and the bigger propeller is going to be a lot more efficient. So the kV doesn't directly affect the efficiency of the motor, but indirectly it does. And I'll talk some more about that some other time. So normally a lower kV value is better, except that there are cases when you may not want that. Of course, if you have an airplane, a Mallard airplane, you need to make sure you have enough clearance with the propeller with the ground. So that may limit the maximum size propeller that you can use. But if it's also like a ducted fan application, you don't have much of a choice there. You just need to run as high a kV as you can, because you need tons of RPM to get thrust out of that ducted fan motor there. So anyway, hope you learned something, and till next time.